When adding a phone line to an underground storm shelter that already has electrical wiring, several options can be considered to ensure safety and code compliance. Firstly, installing a separate 3/4-inch GRC conduit for the phone line from the garage to the storm shelter guarantees physical separation between the electrical and communication circuits. This approach completely eliminates any potential for interference or safety hazards associated with running different types of wiring in the same conduit. Secondly, if running a separate conduit is not feasible, consider using Cat4v Ethernet cable. This cable is rated for both data and communications signals and can be pulled in the existing 3/4-inch GRC conduit along with the 120-volt circuit. It is crucial to ensure that the Cat4v cable is jacketed in plenum-rated PVC for use in an enclosed space like a storm shelter. Plenum-rated PVC provides an additional layer of protection against fire and smoke, which is essential in confined spaces. Thirdly, another option is to install a single-mode or multi-mode fiber optic cable in the GRC conduit. Fiber optics offer excellent signal quality and are immune to electrical interference, making them suitable for coexisting with electrical circuits. However, you will need a fiber optic transceiver at each end to convert electrical signals to optical signals and vice versa. These transceivers add to the cost and complexity of the installation, but provide a robust and reliable communication link. Fourthly, explore wireless communication solutions such as a cell phone booster or a Wi-Fi extender to provide communication within the storm shelter. This approach eliminates the need for any physical wiring and can be particularly useful if running conduit or cables is challenging. Cell phone boosters amplify the existing cellular signal, while Wi-Fi extenders create a local Wi-Fi network that can be accessed by devices inside the shelter. The effectiveness of these solutions depends on the availability of a reliable signal outside the shelter. Fifthly, consider installing an emergency button inside the storm shelter that activates an audible or visible alarm externally. This allows occupants to alert individuals outside the shelter in case of an emergency, even if other communication methods are unavailable. The emergency button can be connected to a siren, strobe light, or other signaling device located outside the shelter. Important considerations include grounding the telephone line properly according to local codes. Proper grounding helps to prevent electrical shock and ensures the safe operation of the communication equipment. Ventilation is also crucial to provide adequate ventilation in the shelter to prevent heat buildup from electrical equipment. Overheating can damage the equipment and create a fire hazard. Ensure that the shelter has sufficient ventilation openings or install a ventilation system to maintain a safe temperature. Lastly, always follow all applicable electrical and telecommunication codes and regulations. These codes and regulations are designed to ensure the safety and reliability of electrical and communication systems. Consult with a qualified electrician or telecommunications specialist to ensure that the installation meets all applicable requirements. When choosing between these options, consider the specific needs and constraints of the situation. Factors to consider include the cost of the materials and labor, the ease of installation, the reliability of the communication link, and the potential for future expansion. For example, running a separate conduit may be the most reliable option, but it can also be the most expensive and time-consuming. Using Cat4v cable in the existing conduit may be a more cost-effective option, but it may not provide the same level of performance as fiber optics. Wireless communication solutions may be the easiest to install, but they may not be as reliable as wired solutions. The emergency button provides an important safety feature, but it does not provide a means of two-way communication. Carefully weigh the pros and cons of each option before making a decision. In addition to these options, there are several other factors to consider when installing a phone line in an underground storm shelter. The first consideration is the type of telephone service to be provided. Will it be a traditional landline, a voice over internet protocol, or a cellular service? Each type of service has its own requirements and limitations. A traditional landline requires a physical connection to the telephone network, while voice over internet protocol uses an internet connection. Cellular service requires a cellular signal. The second consideration is the power supply for the telephone equipment. Will the equipment be powered by a battery, a generator, or the electrical grid? Battery-powered equipment is convenient for temporary use, but it requires regular maintenance and replacement of the batteries. Generator-powered equipment provides a reliable source of power, but it can be noisy and require fuel. Grid-powered equipment is the most convenient, but it is subject to power outages. The third consideration is the surge protection for the telephone equipment. Power surges can damage sensitive electronic equipment. Install surge protectors on all power and signal lines to protect the equipment from damage. The fourth consideration is the environmental conditions inside the storm shelter. Storm shelters can be damp and humid, which can damage electronic equipment. Use equipment that is rated for use in damp environments. The fifth consideration is the accessibility of the telephone equipment. Ensure that the equipment is easily accessible for maintenance and repairs. The sixth consideration is the security of the telephone equipment. Protect the equipment from theft and vandalism. The seventh consideration is the aesthetics of the telephone installation. Conceal the wiring and equipment to maintain a neat and clean appearance. The eighth consideration is the cost of the telephone installation. Obtain estimates from several contractors before making a decision. The ninth consideration is the warranty for the telephone equipment. Choose equipment that comes with a good warranty. The 10th consideration is the reputation of the telephone contractor. Choose a contractor with a good reputation and a proven track record. When planning a telephone installation in an underground storm shelter, it is essential to consider all of these factors. By carefully considering these factors, you can ensure that the installation is safe, reliable, and meets your specific needs. A final point to note is that, in the 2014 National Electrical Code, Article 725.136 covers separation from electric light, power, Class 1, non-power limited fire alarm circuits, and medium power network-powered broadband communications cables. This section requires that Class 2 and Class 3 circuits be separated from other circuits by a barrier or by maintaining a minimum spacing of 2 inches. However, this requirement does not apply if the Class 2 or Class 3 circuits are installed in a raceway or cable tray. Article 800 covers communications circuits. Part Roman 4 of Article 800 addresses protection. Section 800.44 covers overhead communications wires and cables. This section requires that overhead communications wires and cables be protected from contact with electric light or power conductors. Section 800.50 covers underground communications wires and cables entering buildings. This section requires that underground communications wires and cables be protected from physical damage. Section 800.133 covers separation from other circuits. This section requires that communications circuits be separated from electric light, power, Class 1, non-power limited fire alarm circuits, and medium power network-powered broadband communications cables. This section also specifies that communications cables shall be separated at least 2 inches from any circuit exceeding 300 volts. These code requirements are in place to ensure the safety and proper functioning of both electrical and communication systems. Always consult with a qualified electrician and follow all applicable codes and regulations when installing any electrical or communication wiring. Furthermore, it's crucial to understand the differences between the various options mentioned, such as Cat4v, Cat6, and fiber optic cables. Cat4v cable is a twisted pair cable commonly used for Ethernet networks. It supports data transfer rates of up to 1 gigabit per second. Cat6 cable is an enhanced version of Cat4v, offering better performance and supporting data transfer rates of up to 10 gigabits per second. Fiber optic cable uses light to transmit data, providing much higher bandwidth and longer distances compared to copper cables like Cat4v and Cat6. Fiber optic cables are also immune to electromagnetic interference, making them ideal for environments with high levels of electrical noise. When choosing between these cable types, consider the bandwidth requirements of the phone line and any other data services that will be used in the storm shelter. If only a basic phone line is needed, Cat4v cable may be sufficient. However, if higher bandwidth is required for data or video services, Cat6 or fiber optic cable may be a better choice. In addition to the physical installation of the phone line, it's also important to consider the type of phone service that will be used. Traditional landline service requires a physical connection to the telephone network, while Voice over Internet Protocol uses an internet connection. Cellular service requires a cellular signal. If a traditional landline is used, the phone line will need to be connected to a telephone company's network interface device, typically located outside the building. Voice over Internet Protocol service requires a broadband internet connection and a Voice over Internet Protocol adapter. Cellular service requires a cellular signal booster to improve the signal strength inside the storm shelter. The choice of phone service will depend on the availability of these services in the area and the specific needs of the occupants of the storm shelter. Proper grounding is another critical aspect of the phone line installation. Grounding helps to prevent electrical shock and protects the equipment from damage due to lightning strikes or power surges. The grounding system should be installed in accordance with the National Electrical Code and local codes. The grounding conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding conductor should be sized appropriately for the size of the electrical service. All metal parts of the phone line installation, such as the conduit and the equipment enclosures, should be bonded to the grounding system. Ventilation is also important to prevent heat buildup inside the storm shelter. Electrical equipment generates heat, and if the heat is not dissipated, it can damage the equipment and create a fire hazard. The storm shelter should be ventilated to allow fresh air to circulate and remove heat. The ventilation system should be designed to provide adequate airflow without compromising the safety and security of the shelter. The ventilation system should also be protected from the elements such as rain and snow. Finally, it's essential to ensure that the phone line installation complies with all applicable codes and regulations. The National Electrical Code provides comprehensive guidelines for electrical installations, including phone lines. Local codes may also have specific requirements for phone line installations. It's important to consult with a qualified electrician or telecommunications contractor to ensure that the installation meets all applicable codes and regulations. Failure to comply with codes and regulations can result in fines, penalties, and safety hazards. In summary, installing a phone line in an underground storm shelter requires careful planning and execution. Consider all the options, choose the best option for the specific situation, and ensure that the installation complies with all applicable codes and regulations. By following these guidelines, you can ensure that the phone line is safe, reliable, and meets the communication needs of the occupants of the storm shelter. Ensure that the Cat5e cable meets the appropriate standards and is suitable for the intended use. While Cat5e cable can be used for both data and communications signals, it's essential to verify that the specific cable being used is rated for the voltage and current levels present in the electrical raceway. Incorrectly specified cable can pose a fire hazard. When considering wireless communication solutions, evaluate the signal strength and reliability inside the storm shelter. Cell phone boosters and Wi-Fi extenders can improve the signal, but they may not be effective in all locations. Test the signal strength with a cell phone or other wireless device before relying on wireless communication as the primary means of communication. An emergency button can be a valuable addition to a storm shelter, but it's important to consider how the alarm will be received and acted upon. The alarm should be loud enough to be heard by people outside the shelter, and there should be a plan in place for responding to the alarm. The alarm system should also be tested regularly to ensure that it is functioning properly. Remember that any electrical work should be performed by a qualified electrician to ensure safety and code compliance. An electrician can assess the existing electrical system and determine the best way to install the phone line without creating a safety hazard. Obtaining the necessary permits and inspections is also essential to ensure that the work is done safely and legally. Also, document all aspects of the installation, including the materials used, the wiring diagram, and the test results. This documentation will be helpful for future maintenance and troubleshooting. Furthermore, Train the occupants of the storm shelter on how to use the phone line and the emergency button. Make sure they understand how to make a phone call, how to activate the alarm, and what to do in an emergency. Review the procedures regularly to ensure that everyone is familiar with them. Regularly inspect the phone line and the electrical system for any signs of damage or wear. Check the wiring, the connections, and the equipment for corrosion, cracks, or loose connections. Replace any damaged or worn components immediately. By following these recommendations, you can ensure that the phone line installation is safe, reliable, and meets the communication needs of the occupants of the storm shelter. Moreover, consider the long-term maintenance requirements of the phone line and the associated equipment. Phone lines and electronic equipment can degrade over time, and regular maintenance is essential to ensure continued functionality. Schedule regular inspections and maintenance to identify and address any potential problems before they become major issues. This can include checking the wiring for damage, testing the grounding system, and replacing batteries in emergency backup systems. Additionally, consider the potential for future upgrades or expansions of the phone line and other communication systems in the storm shelter. Plan for future needs and ensure that the infrastructure is capable of supporting additional devices or services. This can include installing extra conduit or wiring to accommodate future expansion. Furthermore, it is essential to understand the potential risks associated with installing a phone line in an underground storm shelter. Underground environments can be susceptible to moisture, flooding, and other environmental hazards. These hazards can damage the phone line and other electrical equipment, potentially creating a safety hazard. Take steps to mitigate these risks by using waterproof or water-resistant materials, sealing conduit and enclosures, and providing adequate drainage. Additionally, consider the potential for pests such as rodents and insects to damage the phone line and other equipment. Use pest-resistant materials and seal any openings to prevent pests from entering the storm shelter. Also, be aware of the potential for corrosion in underground environments. Corrosion can damage metal components and wiring, leading to equipment failure and safety hazards. Use corrosion-resistant materials and apply protective coatings to prevent corrosion. Finally, consider the potential impact of the phone line installation on the overall safety and functionality of the storm shelter. Ensure that the phone line does not interfere with the operation of other safety systems, such as ventilation, lighting, and emergency exits. Also, ensure that the phone line is not a tripping hazard or an obstacle to movement within the storm shelter. A properly installed phone line can provide a valuable communication link for occupants of an underground storm shelter. By considering all the factors and following the recommendations, you can ensure that the phone line is safe, reliable, and meets the communication needs of the occupants.